Now we're going to get into simplifying some radical expressions, things with square roots. Number 4, we are doing the square root of a perfect square monomial. In other words, this should come out to a perfect square. When I do the square root, I'm thinking, what times what gives me this answer? Well, I would do the square root of 4. The square root of 4 is 2. 2 times 2 is 4. When I do the square root of y to the 8th, I'm trying to figure out, well, what times what gives me y to the 8th? What happens is because I add my exponents, I have to take half of that. This is a square root. It's understood that that's a 2 in my index. So I would have half of 8, which is 4. The square root of 4y to the 8th is 2y to the 4th, because if you take 2y to the 4th times the second 2y to the 4th, 2 times 2 is 4. I add my exponents. 4 plus 4 is 8. No radical left over because that is a perfect square, and so the square roots canceled out. So if I'm going to do the square root of 16x to the 12th, I'm doing the square root of 16 is 4. The square root of x to the 12th, I do half of my exponents. You can almost read that's a 2. Half of 12 is 6. If I took 4x to the 6th times 4x to the 6th, I get 16x to the 12th. And so number 6, I'm not going to move the board, I think you can still see it. Square root of 36w to the 4th. Square root of 36 is 6. The square root of w to the 4th, half of 4 is 2, going to be w squared. If I took 6w squared times 6w squared, I would get 36w to the 4th. So whenever I'm working with radicals, I am going to take the index and divide it into the exponent. 8 divided by 2 is 4.